In the midst of World War II, while Europe was burning in chaos, something extraordinary was happening inside a Soviet hangar. Before the engineers stood a machine they had never seen before. The American medium tank, the M4 Sherman. Sent through the Lend-Lease program, it was meant to help the Allies in their fight against Nazism. But for the Soviet specialists, it was more than just a vehicle. It was a different world. They opened the hatches, looked inside, touched the metal, the wires, the systems that worked completely differently from their familiar T-34s. And what they saw inside sparked surprise, respect, and even doubt. How could a machine, built across the ocean, be so simple, and yet so complex? And what exactly astonished the Soviet engineers when they dismantled the Sherman down to its last bolt? At the beginning of 1943, the situation on the Eastern Front remained critical. The Battle of Stalingrad had brought victory, but at a terrible cost. Thousands of tanks and vehicles were gone, fuel supplies were shrinking. And Soviet industry, evacuated to the Urals, was operating at its absolute limit. On the other side of the world, in Washington and London, the Allies watched closely. President Franklin D. Roosevelt understood that the fate of Europe depended on whether the Red Army could endure. "We must be the arsenal of democracy," he had declared in 1941. And by 1943, America had truly become that arsenal. Under the Lend-Lease program, the United States supplied the Soviet Union with weapons, vehicles, fuel, food, everything that could bring victory closer. The total value of aid exceeded $50 billion, an astronomical sum for its time. For the Soviet Union, these shipments were not just assistance. They were lifelines, steel arteries stretching across oceans. Connecting two worlds united by a single purpose, to destroy Nazism. The routes, however, were deadly. Arctic convoys to Murmansk sailed through storms, ice, and the ever-present threat of German U-boats. In the North Atlantic, every ship risked being sunk. The tragedy of convoy PQ-17 became a grim symbol of that danger. Out of 35 ships, only 11 reached the Soviet shores. And yet, the convoys continued to sail. Another route, through the Persian corridor, carried supplies across thousands of kilometers, from the ports of Iran, through the mountains and deserts, to the Caucasus and then to the front lines. A third route, across the Pacific to Vladivostok, operated quietly under the guise of commercial shipments. Allowed only because the USSR still maintained neutrality with Japan. Alongside British Matildas and Valentines came the American M3 Lee and, later, the M4 Sherman. Together they became symbols of Allied unity, Roosevelt's iron gifts, as Soviet soldiers called them. In total, the Soviet Union would receive over 4,000 Shermans. Each one traveling through fire, ice, and storm to reach the front. The Americans designed the Sherman not as a monster of armor, but as a universal workhorse for mass production. They valued reliability over raw power. For them, it wasn't a miracle weapon, but a logical, standardized, soldier-friendly machine. Easy to maintain, comfortable for the crew, and built for long campaigns. Soviet engineers, accustomed to the harsh simplicity of the T-34, were astonished. Electric lights inside the hull, soft leather seats, a heater, even a functional radio. All of it seemed unnecessary, even extravagant. One Soviet mechanic would later recall. When they said the tank had interior lighting, we asked, why would anyone need that in war? But as time passed, astonishment turned into respect. The Sherman was different, and in that difference lay its strength. Its smooth ride, its precise aiming, its carefully designed ergonomics drew admiration and curiosity alike. The Americans, it seemed, fought their wars differently. With comfort, calculation, and a vision of endurance. When the first Shermans arrived at Soviet testing grounds, engineers gathered around them like men encountering a visitor from another world. They examined every bolt, every wire, every instrument. And slowly, they began to understand. This was not just a gift from an ally. It was a window into another civilization's way of waging war. Spring, 1943. Inside a large hangar near Moscow, dozens of engineers and mechanics gathered from factories across the country. In front of them stood the dark green silhouette of a new tank, freshly arrived from Murmansk. On its sides, American markings. On its tracks, traces of northern salt and rust. It was the M4A2 Sherman, powered by a General Motors diesel engine. As the engineers approached, silence filled the hall. No one spoke. They studied every contour, every detail, trying to understand the logic of a foreign mind. Then a short command broke the stillness: open the hatches. The examination began. Inside, everything was neat and organized: labeled cables, clean panels, clear inscriptions in English. For Soviet mechanics, this was almost a shock. They were used to crude metal, minimal comfort, and machines built purely for function. Here, everything looked designed with the human in mind: handles on every module, proper lighting, padded surfaces. One engineer later wrote in his notebook, "It feels more like an American automobile than a tank. Everything here is made for the man, even where we'd expect a wrench." The tests followed. When the engine was started, the crowd exchanged surprised glances. The sound was smooth, steady, without the harsh metallic roar they knew so well. "It runs like a tractor," someone said. "Only, smoother than any tractor I've heard." The Sherman sent to the USSR used a diesel variant, built especially for Soviet deliveries. Since most American Shermans ran on gasoline engines. That detail alone impressed the specialists. The Americans had adapted their tank for Soviet fuel logistics. When the machine moved forward, everyone noticed the suspension. The American VVSS, the vertical volute spring system, gave the tank an almost graceful motion. No rattling, no shaking, the crew felt far less vibration than in any Soviet tank. Even on rough ground, the Sherman held steady. A young tester remarked, "In the T-34, after an hour, you feel every bolt in your spine. Here, it's like riding in a truck." The radio system left an equally strong impression. The sound was clear, steady, reliable. For Americans, a radio was a necessity. In many Soviet units, communication still relied on flags and hand signals. Then came the gun test. The 75mm M3 cannon had a gyrostabilizer. A device that kept the gun aimed even as the tank moved. For the Soviet testers, it was almost unbelievable. "You can fire without stopping," one officer exclaimed. Yes, that was precisely the point. The Americans valued constant motion and sustained firepower. Engineers took notes, made sketches, photographed every detail. Some shook their heads: too complicated, too bourgeois. Others simply stared in admiration. Before them stood a tank that combined technology, comfort, and logic, in equal measure. When the first day of testing ended, a short entry appeared in the Proving Grounds Journal. "The American tank impresses with its organization and build quality. Perhaps we, too, must learn not only to fight, but to design with people in mind." After the first field trials came the most important stage, the technical autopsy of the American tank. The captured Sherman was rolled into a large workshop on the outskirts of Moscow, under the supervision of engineers from several design bureaus. Their task was to take it apart, not to copy it, but to learn from it. Every nut, every bolt, every cable would be studied and catalogued. The inspection began with the heart of the machine, the engine. In front of the team stood the General Motors 6046 power unit, two 6-cylinder diesel engines linked through a common crankcase. It produced around 410 horsepower at 2,100 revolutions per minute. For Soviet specialists, the twin-engine layout looked strange but ingenious. If one engine failed, the other could still keep the tank moving. A principle of redundancy that American designers valued greatly. The cooling system impressed them most: 2 compact radiators, a carefully arranged airflow, and maintenance panels large enough for a mechanic to reach every valve. Fuel filters were placed at easy access points, and the lines were marked with color-coded tags. Compared to the rough layout of the T-34, this looked almost like laboratory precision. Fuel consumption was surprisingly moderate, roughly 170 liters per 100 kilometers. Thanks to efficient fuel injection and a well-balanced gear ratio. "They have thought of logistics," one Soviet officer noted. "We think of power, they think of endurance." Next came the transmission and steering system. The mechanical twin-disc gearbox ran smoothly, with little vibration. Hydraulic assist mechanisms reduced driver fatigue. "The controls are soft," an engineer observed. "You can turn this tank with your fingertips." On the T-34, steering demanded physical strength. The Sherman could be driven by precision, not muscle. When they examined the suspension, everyone paused. The VVSS system, the vertical volute spring suspension, was both simple and refined. Each bogie worked independently, smoothing the ride over rough terrain. To the Soviet testers, used to the harsh jolts of Christie suspension, this felt almost luxurious. During test runs, the gun sights barely shifted even when crossing ditches. The Americans had built stability, not speed, and that stability saved lives. Engineers also took apart the gearbox casing, finding beautifully machined parts and clear serial numbers. It was evident that the tank was designed for interchangeable production. A part from one Sherman would fit perfectly into another. That level of standardization amazed the Soviet observers. "In our factories, every machine is slightly different," one inspector sighed. "They have built an army of identical twins." The turret and main gun became a separate chapter of study. The 75mm M3 cannon was shorter than the Soviet 76mm gun, yet it had superior balance and easier elevation control. The gyrostabilizer, a compact, humming device hidden under the gunner's seat, became a subject of fascination. When activated, it held the sight line steady even as the hull rocked. It allowed a Sherman crew to fire accurately while on the move, a tactic unheard of for Soviet crews at the time. "They shoot while rolling," a gunner exclaimed, and they hit. The optical sight, the M70, offered 5 times magnification and crystal clarity. Soviet lenses, often clouded or poorly aligned, could not compare. The sight even had a tiny electric defogger built inside, a detail so small that it drew applause in the workshop. Inside the fighting compartment, the impression deepened. Adjustable seats, well-padded backrests, labeled ammunition racks. Wiring harnesses bundled neatly in protective sleeves. Automatic fire extinguishers mounted by the engine wall. "This is a tank built by people who drive," one Soviet technician said quietly. "Not by people who only design." The radio equipment, the SCR-508, provided stable communication up to 10 kilometers, with clean reception. To an army that still used flags and signal pistols, this seemed like science fiction. American crews could coordinate movements between platoons without leaving their vehicles. An advantage that would later inspire changes in Soviet armored command systems. The armor became a point of debate. The frontal plate, 51 mm thick, angled at 56 degrees, looked modest. But the sloped geometry increased its effective resistance dramatically. Test firing showed that German shells at medium range often ricocheted. The Americans had not relied on brute thickness, they had used geometry and materials. Armor plates were rolled steel, heat-treated for consistency, a far cry from the sometimes brittle castings on early Soviet models. Even the surface finish impressed the visitors. Smooth welds, corrosion-resistant coating, and uniform paint thickness. Not for beauty, but for maintenance and camouflage efficiency. Serial numbers were stamped everywhere, proof of industrial discipline. The engineers also examined crew safety systems. The Sherman had 4 hatches, 2 on the hull and 2 on the turret, placed to guarantee escape even if the gun jammed. On the T-34, front hatches were often blocked by the gun's recoil system, trapping the crew inside. The difference was philosophical. The Soviets built tanks for victory. The Americans built them so their men could return home. Over several weeks, the team documented thousands of details, drawings, photographs, even chemical samples of the armor and lubricants. They found that the Sherman's reliability came not from superior genius, but from planning. Parts designed for easy production, logistics built into engineering. The tank was less of a weapon, more of a system. When the study concluded, the commission issued a final note. The American tank is not stronger than the T-34, nor simpler. But it is thoughtful in every detail and remarkably consistent in manufacturing. Its greatest advantage is its human orientation. Designed for the crew first, and only then for the war. For many Soviet engineers, that conclusion was a revelation. The Sherman taught them not just about machines, but about the value of comfort, reliability, and standardization. It raised a quiet question that would echo long after the war. Could the soul of Soviet engineering ever meet the precision of the American mind? After several weeks of testing and analysis, the Soviet engineers compiled a comprehensive report. For the first time, one word appeared at the top of the page: comparison. Because every study only becomes meaningful when you can say, what was better, and what was worse. Naturally, they began with the symbol of Soviet armor, the T-34. At first glance, the two machines looked like products of entirely different worlds. The T-34, born in war, simple, rugged, almost brutal in its purpose. The Sherman, logical, balanced, built not just to fight, but to last. The engineers started with what could be seen immediately: the silhouette, armor, and dimensions. The Sherman stood nearly half a meter taller and had a wider turret. On the battlefield, that made it an easier target, but inside, the crew had space to breathe and work efficiently. The commander had his own cupola with a panoramic view. While in the T-34, he was also the gunner and observer, 3 jobs in one man. In the American tank, each role was separate, which meant better coordination and faster reaction. Visibility became one of the key differences. The T-34's viewing slots were narrow and heavily armored, limiting the field of vision. The Sherman's cupola, by contrast, offered a near 360-degree view with multiple periscopes. You can actually see the battlefield, one Soviet tanker wrote in his diary, not just the horizon. Next came mobility. The T-34 was famous for its speed and ability to handle mud and snow, up to 50 km/h on open ground. The Sherman was slower, about 38, but far smoother. It didn't bounce violently over rough terrain, and that stability meant more accurate fire and fewer mechanical failures. In our tank, you feel every bump, a tester joked. In theirs, you just drive. Engines were another contrast. The T-34's V2 diesel produced 500 horsepower, raw and powerful, but required careful maintenance and clean fuel. The Sherman's General Motors diesel was weaker but ran reliably, even when partially damaged. One engineer wrote, "If we had American logistics, our T-34s would be unstoppable." But in real combat, the Sherman was simply more predictable. Then came the guns. The T-34's 76mm cannon fired faster rounds, but the tank had no stabilizer. To fire accurately, it had to stop. The Sherman's 75mm gun could fire while moving, using its gyrostabilizer to maintain aim. It wasn't just technology, it was a different mindset. The American tank was designed to keep moving, to stay in motion, and to fight on the move. Inside, the difference continued. The Sherman's ammunition was stored neatly in sealed racks. In the T-34, shells were often placed underfoot or behind the crew's seats. It was faster to reload, but deadly if hit. The American solution was slower but safer. Optics and sights revealed an even deeper divide. The Sherman's telescopic sight was bright, clear, and even had a small internal heater to prevent fogging. Soviet optics were simpler, darker, and often misaligned. They aim with precision, one tester wrote, we aim by habit. Then came communication. Every Sherman carried a standard radio, reliable, easy to tune, and always on. In the Red Army, only command tanks had radios, others used flags or hand signals. That single difference changed the flow of battle. American units could coordinate, adjust, and respond faster, not through bravery, but through information. Armor and survivability were another philosophical split. The T-34's sloped armor provided excellent deflection, but when penetrated, fragments often ricocheted inside, causing heavy casualties. The Sherman's armor was thinner but more ductile, less likely to shatter. Its fuel tanks were isolated and fitted with automatic fire extinguishers. Fires were rare and short-lived. Our tank fears fire, one Soviet mechanic admitted, theirs prevents it. Ergonomics, a word rarely used in wartime reports, became a real discovery. The T-34's crew of 5 worked in cramped conditions, vibration and noise were constant. In the Sherman, there was space, ventilation, padded seats, even electric lighting. Soviet crews who first sat inside laughed, you could almost live in here. Yet not all impressions were positive. Some Soviet officers dismissed the Sherman as a parade tank, too tall, too delicate for the Eastern Front. In harsh winter conditions, it required care, clean fuel, maintenance, lubrication. And in that, the T-34 remained king, simple, rugged, indestructible. It didn't need comfort. It needed to move, shoot, and survive. For balance, the engineers compared the Sherman with heavier Soviet tanks, the KV-1 and KV-85. Against them, the American machine clearly lost in armor thickness. But it surpassed them in maneuverability, mechanical reliability, and repair time. The KV was a fortress, the Sherman, a tool. You could fix it in a field, and it would fight again within hours. In the final summary, the Commission wrote a single phrase that would later become famous. The T-34 is a tank for the front. The Sherman is a tank for the soldier. Those words captured everything. The Soviet tank embodied strength, sacrifice, and simplicity. The American tank, comfort, foresight, and human care. Both philosophies made sense. The Soviet Union built in desperation. The United States, in precision. And somewhere between those two worlds, between brute force and thoughtful design, lay the secret of the Allies' victory. When the study of the Sherman finally ended, the Soviet engineers returned to their design bureaus. But the memory of that American tank stayed with them. Each man carried a quiet question in his mind. Why was it so different? The Sherman was never copied. It was not a model to imitate. But it gave something far more valuable, an understanding of philosophy. That a tank was not just a weapon, but a system. Where every bolt, every cable, every inch of space served a purpose. And where the crew was part of the design, not an afterthought. By 1944, traces of this new thinking had already appeared in Soviet projects. Tanks like the T-43 and T-44 introduced wider hatches, better ventilation, and safer ammunition layouts. Later, in the designs of the IS-3 and early T-54, official documents began to use new terms. Crew comfort, radio communication as standard, balanced suspension. Such phrases had never appeared before the war. They entered the vocabulary only after the Sherman study. At the Kubinka Tank School, a new course was added. Analysis of Foreign Military Technology. Its motto was simple: the enemy teaches no less than the ally. In lectures, American engineering solutions were dissected not with envy, but with respect. This is not weakness, one instructor said. This is experience. The Sherman became a kind of window into the future. Proof that mass production could still mean precision. And that crew comfort could coexist with speed and efficiency. It was a lesson in industrial thinking. One the Soviet Union would later apply to its own factories. And even if history rarely mentions it, many engineers who later worked on the T-54, T-55, and T-62 admitted in their memoirs, "We looked at the Sherman and thought, that's how you design for the man inside the machine." The influence of the Sherman cannot be measured in parts or blueprints. It is measured in perspective. The Soviet design school remained true to its simplicity. But after meeting the Sherman, it gained something new. A sense of humanity in engineering. And when, a decade later, new Soviet tanks rolled off the production lines, they were no longer just armored beasts. They had become instruments of thought and experience. And a small part of that experience. When the engines fall silent and the tanks stop moving, what remains is not steel, it's experience. The Sherman and the T-34 never faced each other as enemies. They fought side by side, in different armies, but for the same cause. And that is the irony of history. Sometimes, it's not the battles, but the learning that becomes the true victory. Two philosophies, American and Soviet, met at the edge of human endurance. One sought efficiency, the other simplicity. But both taught the same lesson. Those who learn, survive. The Sherman taught Soviet engineers to see machines through the eyes of the man inside. The T-34 taught Americans to value speed and raw practicality. And though they stood on opposite sides of an ocean, between them ran an invisible line of understanding. That true power lies not in armor, but in the mind that forges it. After the war, the world split in two. But technology continued to speak a common language, the language of experience. Tanks evolved. New generations appeared. Yet inside every one of them lived a fragment of 1943. A time when engineers were not just building weapons. They were learning to understand both the enemy and themselves. And today, when we look at an old Sherman in a museum, or a restored T-34 gleaming under the sun, we no longer see just armor and steel. We see people. People who learned in the hardest way possible. Who carried from war not only scars, but wisdom, the knowledge that every bolt, every hatch, every line of a blueprint is the story of someone's life. Because the history of machines has always been the history of people. And even in the darkest of times, humanity never stops learning.